All right. Now that is fixed, now we've got the sketch fixed for the holder. We can use it to extrude out. So for that, we select the sketch, we select pad. Now we're going to want a fair bit, so have a look at a I reckon it's going to need to be make it solid enough. I'm thinking pretty wide. I'm thinking we go to 80. We'll give it enough rigidity so it doesn't wobble around too much. So I'm going to go 80. Yeah, and I think for now, what I need to do is I need to move the sketch, actually. So I think we need to make a datum plane. And then we could do like a 2-direction pad on this. 2 dimensions. So we go like 40 and 40. About a center. And then we can put a datum plane at the center here, and that'll kind of sort that out. So let's do that. So we can create a datum plane. We'll select that and we'll go create plane. And we're going to move it in the Z direction. It's going to be 229 divided by 2. Get it halfway. Now this datum plane's in the wrong place. We need it before the pad. Just come before that. So we'll go move object after another object. Select a feature from the list. It's going to be after mirrored 002. Goes there. Rearrange time a little bit. And then we can attach the sketch. Change the attachment support to the datum. Now, I don't... Okay, that did work. That's great. So now we can recompute that and... Oh, perfect. Now, looking at this, though, I did want to not have to have supports. I still don't. So I'm thinking this actually does need to be a separate body that we attach afterwards, and I don't mind that. I think I'm going to get a stronger, cleaner result by having this as a separate body afterwards. So because of that, I think what I'm going to need to do is actually... I'm gonna need to create another body, and we're gonna call this one glass holder mount. And we got the origin for that. We'll close holder mount. So really, okay. Now we're getting into some more advanced moving stuff around here. I need to get these 2 things here and the sketch into this without making like this whole crazy copy of everything else. I just need to be able to move these objects into here. So I think a part of that is going to be, because what's attached to what, right? We can create the datum plane really easy. I don't think I need to bring that across. But the sketch and the pad I do want to bring across. So I think to make life easy on myself, what I'm going to do start here. We'll create the datum plane. Active body required. Yeah, all right. Auto mount. Select that and we'll create the plane and we'll move it out in the Z direction by 229 divided by 2, which is halfway. Number we know very well now. I can turn that origin off. I can delete this datum plane and it's going to break the sketch, which is actually fine because we don't want it attached to anything. The only issue I'm seeing here is that we do have an external geometry. So it's possible maybe I should go into the sketch and actually get rid of that. And we'll get rid of these coincident constraints that attach to that external geometry. And we'll make things easier for us to see. We'll turn that off. Don't know what I just did. Dang it. Okay. It's under constrained. All right, that's fine. All right, so this length here we're going to need to say is 10. And it's also going to need to be horizontal. So now we should, yeah, right. Okay, so we've only got 2 degrees of freedom now, which is X, and Y. And we can now delete this external geometry. So close. Now we've got no external geometry. We've got no attachment. So in theory, I should be able to bring the sketch into this object. Beautiful. Wow, it actually worked. I'm actually having some success with moving stuff around today. Did it bring it into there, or is that not? Wait, hang on. Is it baiting me here? I think it might be. I don't know what is going on. I think something is broken. Maybe not. There we go. Move that into there. Turn that off. Okay, we can delete this now. Now in here, this is where the shape binder thing comes in. I'm starting to get used to this idea now. So we can go on this object here, select the face, and we can do a sub-object shape binder. Now I can't remember the exact difference between the sub-object shape binder and the shape binder. I think maybe the sub-object one, I think, can actually go cross different bodies. I think the shape binder is internal to the body only. I think that is the difference. So we want a binder. Now we can turn that off. We've got everything we need to get this sketch sorted. So now the sketch is actually in the right place, but that's just a hangover of cutting and pasting it when it was broken. It just kind of stayed in the same global space. So we still need to attach it. It's still not attached. So attachment editor, we're just going to go plain face and we're going to choose that, our new datum plane. So the sketch is now bound to that datum plane. And we want the binder before, we actually want the binder like right at the front of this. So we are going to do that. We're going to go move object after another object, and we're going to go beginning of the body, because if we were building this is kind of the reference we were using. So yeah, that makes sense. Now the thing is, I actually don't even need this datum plane because this is a separate object and I'm going to be assembling it different. So we don't need to be building it in place. So I think maybe the better way to do this is actually to base the sketch on the YZ plane here. So attachment editor, Z, go okay. Yeah, that's better actually. So now we can go into the sketch and we've got this shape binder here. And so we should be able to, because we've still got these degrees of freedom, we should be able to bring in the external geometry from that binder. So see, this is another thing, like in Fusion, and I don't know if I like this because in Fusion, this is weird. I'm becoming a bit of a convert here. In Fusion, if you had another geometry showing in the sketch at the same time, if you had it unhidden in your tree and you moused over it, it would actually highlight it and you could just click on it and it would automatically bring it in. In FreeCAD here, why are there two sketches? I don't know what is happening there. Strange what's going on with that one. Anyway, let's just go in here and do this thing. So in FreeCAD, you have to be quite deliberate about it. So we have to like go create external geometry. It's a separate step. So I have to click on this, and then I have to click on the thing I want to bring in. So I'm only going to bring in a point. I'm going to bring in a single point on the corner here. That's it. All I need, because I've now, I mean, see, I could length the length of these things, but even if I extended this out, it's like, do I want that to extend out the same? I don't know, maybe not. So I want that control. But what I do know is that this corner needs to meet this corner. So we can select those 2 points and we can create a coincident constraint. That means our sketch is now fully constrained. Nothing in this sketch can move. Now, so we don't need the binder anymore, but what we do need is the sketch. And with the sketch, we are going to pad it out, and we're going to pad it out by 80 millimeters, which is what we decided before. And we have our glass holder mount. Now, if I turn on the bottom part, it's nicely, you know, nicely aligning there, which is fine. That's not where it's actually going to be. Whoa, that looks way wider than I thought. Maybe this isn't high enough. Maybe that's got to go a lot higher. I think it does actually. So we're gonna look into that. We're gonna go sketch, and we're gonna change that to like, maybe we'll change that to 80 as well. We'll just make it 80 by 80. There we go. It looks quite weird being square. 80. I don't know. Maybe I should go to 100. Just throwing me off until I see it all together. It's not going to make a lot of sense. So yeah. I'm actually going to roll all this back because I top / bottom. Yeah, I made a bit of a mistake thinking I could do all this as one part. For 3D printing purposes, it's going to be way easier if I print this separately, because I can just, like, none of this thing here is not going to need any supports. This here is not going to need any supports. So I'm going to get a better result out of that. So now if we see how it's actually going to all sort of fit together, it's going to go like this. That's going to move up and down, and yeah, it's going to attach to the glass holder like that. Hopefully be rigid enough to hold it all together, but I guess we'll see when we get the glass made and this made. We can print it with quite high density, choose a good infill pattern, which is going to help with rigidity as well, do all that sort of stuff. So yeah, we'll look at that a bit later on. Okay, in terms of what to do next, I think for now I want to get this assembly sorted out. Well, now I don't know where. Okay, I do know where. What we need to do is turn off everything that's not in the assembly so far, and we need to bring in, we need to go to the assembly work. If we double click on that, does it open the assembly workbench? It does. That's quite nice. All right, so we're going to bring in a body again, and it's going to be the top bottom, and that's going to be in exactly the right place. No, it's not. Nothing's in the right place, actually. I remember now we put everything in roughly. So we're going to bring in the glass holder mount as well. The glass holder mount is going to go centered like that. Oh, this. Okay. Okay. All right. We're we're good. Are we? Am I good? Doesn't sound. So how do I like? I've got this whole blimmin' trackball orbit style turntable. That's what I want. No, is it? Turntable's what I like. Hey, trackball's the weird one. Yeah, trackball's the one. If you do the same movement, it slowly rotates. I don't get trackball movement at all. What about I think the one I like is, I don't know what free turntable is. I mean, that doesn't feel great either, actually, to be honest. It's turntable. I think turntable's still my fav. Still me fav. So left and right, up and down. Fix. A little weird though. I don't know why this suddenly feels different. Whatever. Okay. That works. This is so frustrating. Where? Good. We'll leave it there. It's fine. Close enough's good enough. Let's turn that off. Close that. Glass holder mount. Okay, we have now created that part. Well, not completely, because now we need to work out our, go back to our design here and work out the next part. So that's that bit there. Look how tiny that one is. That's like 50 mil maybe. Anyway, so we need the, now we need the tablet holder and the post for the screen. Now I reckon the tablet holder and the post for the screen are all one unit. Well, I mean, the tablet holder is going to be made up of different units. I think the post holder, okay, I think I have an idea of how to do this. I think we go back into, I think we put this on ice for just a minute here, and I think we actually create a new so that's actually a different document. Is this like a workspace or something? Is this what we're looking at? We've got two different documents open. So I don't know if I like that. How do we, I don't think I want to do that. Add dependent objects. Link actions. Make link group links. The different documents, you see. I don't know what the recommended workflow is in FreeCAD for this kind of thing. So I understand bodies. So I've got bodies. Art design. I'm thinking of Fusion 360 where there's components and components are made up of bodies. I don't think Part is a general purpose container to keep together a group of objects so they act as a unit. Right, okay. That's what I want. That's exactly the thing that I want here. So we want to go back to TelePunk here. In fact, I'll delete unnamed if I can. Close document. Okay. We'll go recompute. So pretty much all of this is one part. So we'll link that all together. Part. So this is the glass frame and mount. Okay. So, and then the next part that we're going to build is a, this is going to be the tablet holder and glass post. Now, I was weighing this up, and I think I've made a decision. I think what I'm going to do, if we go back to Creative for a second and design this out, I think the tablet holder is going to be that's going to have a couple of different parts. So we're going to have the part that the tablet rests on, and this slides on here. So this is like this is the glass mount post. And this thing here is what we just built. So this is that and I reckon underneath this, I think, I'm not 100% sure about this yet. Underneath here, I was going to do some posts. So this was going to be like standard standard posts that let's grab selection. There's like this matte box mounting posts. I need to figure out what the standard is for those. That box. Small rig. Oh, it's like, I mean, maybe there is no standard. Maybe there isn't actually. I'm pretty sure there is though. Let's go small rig and see if they've got anything like that. Stabilizer accessories. Small rig makes some really cool stuff, so we like them. Ooh, look at that. I've got one of those Samsung SSDs. Yeah, these 15 mil rod clamp. That's it. 15 millimeters. Okay, fine. So 15 mil. So we're going to say 15 millimeter. And on that note, like if we go like Bunnings, do they have 15 millimeter rod? Stainless steel hanging rod, 15 by 1 PVC pipe, fiberglass, 15 millimeter fiberglass. Okay. I mean, that's not bad actually. Like, could use fiberglass. Very light, very strong. Probably quite move and sway in windy conditions. Now it needs to be more rigid than that. I can't have it bending around. 15 millimeter aluminium tube. One Bunnings Warehouse. Rapid mesh 16. See, that's annoying. 16. It's all 16 mil. Aluminium online. Straight aluminium tube. Gordon Harris KNS aluminium tube. I mean, they wouldn't hold this in store, would they? What are the standard? Let's have a look. Standard film rods, matte box. Like, I don't know. $15 millimeter. It certainly does seem like 15. This is insured by the standardized rod system. Geez, there's a lot of questions. So yay, matte boxes. Yeah, there is in fact a universal standard for 15 mil rods. They'll be using the 15 millimeter LWS optically centered standard. So 15 millimeter rods, right? So I wonder then, in that case, I want it cheap. So a 15 millimeter rod. Let's just see if we can buy them. So 30 centimeters, 2 pieces for $30. I mean, really, that's not bad. It's not bad. And they've got 12 threads in the end of them. See, I don't hate that. $20 centimeters for $26. Photo gear, $12. Oh. It would be nice not to have to buy Such a pain. It's 16 millimeter. I know I've run into this problem before, and you just cannot get 15 millimeter outer diameter rod cheap places. Not a standard size for some reason. It'll be one of those disappointing things where if I compromise and just went, oh, I'll just use 16 mil, it's no good for people who are using proper stuff as well. People who actually have 15 mil tubes. More aluminium rod. Large aluminium. ANS. So I wonder if I just search for that brand, A and oh. 3 pieces, 3 sizes. Nice to know what sizes they are, though. Comes in a variety pack. Okay, well, you know, I love a bit of variety, but it would be nice to know what variety I'm getting here. Number 5074, ANS 5074. 3/16 inch, 732 and 1/4 inch. So what is 15 millimeter in inches? It is 1932. Yikes, man. Like, is it seriously that hard to find a piece of 15 millimeter tube? Copper tube, standard gauge, 15 millimeters. Now, I do have copper, actually. I do have copper tube. Which I could use. Be a bit random for now until I find a place to get 15 millimeter aluminium from. See, a meter of the stuff for 22 bucks. I mean, that's not bad. It's not like, I mean, those professional aluminium tubes, though, are like not much more expensive. And this, I don't know. I mean, this is, I don't know what the wall thickness is of this. Not much by the looks of that. Millimeter. Maybe 1.2. That'd still be pretty strong, I reckon. Oh, we'll go for that for now. We'll just work with 15 mil. It is the standard. That's what I want. I want the standard regardless. So we use that. Okay, back. We are going to go tablet, holder, and glass post. So again, thinking of how I can make this good for 3D printing as well. So this is where I need the tablet, and I need to get the dimensions of the tablet, and I'm just going to use my cheapo one for now, my smaller tablet. I mean, what I could do, I mean, I guess a lot of people are going to use iPads, right? So maybe an iPad would be a good model to go off. And I could even bring in an iPad model into this as a reference to build off. So let's do that actually. Let's go iPad. All right, actually, what generation iPad are we at? 10th. Apple iPad. 10th gen. 10th gen iPad STL. Yigi, Colts, GrabCAD. GrabCAD usually works pretty well. Apple iPad 10th gen, download files. Thanks, buddy. So we'll cut that. We'll go to our projects folder. And I know I created a thing here, TelePunk. We'll paste that in there. We don't need these pictures. Just need the step file. So we'll go back to FreeCAD. Bring up that. Oop. Compound merge will be done. Slower but higher details. Use link group. Important visible objects. Reduce number. And compound. Node. Document. I don't know what all that means, so I'm just going to go OK. Yeah, I'm happy with that. I don't know why it comes in on some... Oh, it's because I am on some random angle, that's why. Okay, so... we just... Yep. Not be at these crazy angles anymore. I feel like this whole thing needs to turn around. It's... This glass business is annoying me a little bit. So, what I do wonder then is it going to make sense for me to rotate this around? But it's going to screw everything up in there as well. So maybe not. I don't know. Let's see what happens if we do that. If we go transform and we're going to go rotate like that. And then we go into this and like edit something in here. So we turn on the origin. The origin's all weird, right? The origin's been rotated around. Which, I mean, it's not terrible. I mean, that kind of makes sense, but the global, oh, I don't know. Maybe just for this, and we can always reset it back afterwards. Okay, so let's go iPad, let's go transform, let's rotate it flat. Rotate it flat. Okay. That's quite a few parts in here, right? Actually, oh, this is so annoying. The Control Z doesn't do what I expect it to do sometimes. Okay, we'll rotate around that way, and we'll just leave it at the origin, because really I don't need to see this glass holder while I'm working on that. So this might be one of those cases where bringing it to the origin, or putting this thing at the center, actually makes a little bit more sense. So I'm going to be working on the tablet holder here. We can turn on the origin. Okay, so it is. It's actually on the center already, so that's kind of nice. Now let's see if we can make that a bit transparent. Maybe I should start with primitives again. Attach to... Is there a way you can like lock, toggle selection, hide selection, toggle selectability? So that's not selectable anymore. All right. So back in here, oh, we actually need to go back into, we are in part design. So tasks, we're going to go cancel. We're going to create a new body. And this body is going to be front lamp. And I almost feel like this could be a sketch. I feel like sketch workflow is going to work for this. Kind of annoying how it always flips it round. So the camera side is considered sort of the top of the iPad usually, isn't it? So that's kind of, this is the front here. So this is where, is it, see, is that around the, it is. So that's the front. Okay, that does make sense. So basically we'll do a polyline. We will, now I understand the angle thing now. I get why that is. Why it is how it is. Because the angle thing, like basically, it's self-adjusting. So for the thickness of the item, in a way. Move that down there. Cool. Now, okay, this is going to confuse me if I'm not around the right way. So, front. What? Better. Okay. We've got horizontals. This is going to be pressing escape all the time. Doesn't do anything. Okay, these are going to be angles, so we'll measure that 135 degrees. These two are going to be parallel. These two are going to be parallel. This here is going to be perpendicular. This here is going to be perpendicular as well. Okay, so that's good. Now what we need to do is give some things some sizes. So I reckon we base this on 15 mil. That on 15 mil. I think we stick to our, what do we think, 3? 3 mil? Is that enough? 3. 1, 2, 3. It's pretty thin. Actually, that's really thin. If I look at a device I've got here, let's see what they build it at. Yeah, 5. So I reckon we do the same. Five. We'll give it a go. I mean, we can always make this thing prettier afterwards, you know, like. We want it reasonably rigid, so it's all good. That is going to be 5 as well. Okay, so now this thing should move around all together like that. Definitely not constrained yet. But this is a sketch, so this sketch shouldn't be driven. Gee, that's a tricky one, because in some ways we do want the iPad as the center focus here. So maybe what I'll do, I'll just go 7 mil. And we'll, because we still don't know how long this is, so maybe I should give that a dimension as well. We'll go 130 mil to start off with. Actually, maybe less. 130? Yeah, 130. So we want a minimum size as well. And ideally, you'd want to be able to put a phone in there. And I don't see why still wouldn't be able to. If this thing, if like the base that this slides on actually comes out further. I don't know. 100 mil for now. We'll work with that. We'll see what we end up with in the end. And this might be too large. I think we might be talking more about 10 mil. In which case that can go down to like 3. And we'll make that 12. Okay, so now we're fully constrained. Close that off. With a sketch, we can pad it. We'll go 2 dimensions. And just get a reference. Our 65. So we'll go 70. So we'll go 35 each side. Okay, so that's 3D printable without supports. We got 45-degree angles there, which are okay. You know, maybe this doesn't have to be 5mm thick because it's not taking most of the weight. I think what's taking most of the weight is actually the thing that this slides into. So I don't think that needs to be that thick. I think we can get it down. I think we can get it down to 3mm quite comfortably, actually. Down to 3mm. That does feel better. Does look better. We'll round this off. We'll do some pretty stuff to it afterwards, but like, I think that's good for. So now we need. So that's the front clamp, and now we're going to do the back clamp and post. So we will add in another part, and we'll call it back clamp post. Now, ideally, again, this will be all 3D printable in one hit. So let's turn on the origin for this one. We're going to go... what's going to be a good way to look at this? I think in this case, we're going to build a sketch from this side, from the XZ plane. We're going to do a sketch there. That way we can see, yeah. So this one is going to look something like this. Some sort of shape like that. And now we can add some constraints. So this one here, we're going to add a, we'll stick with a 3mm as kind of a standard thickness there for narrow things. That one there is going to be 0.5mm clearance either side. So we'll go 71mm for that, I think. And then that means that that one already has length. We can constrain that one horizontally. We can set the distance here because we want to know the thickness. We want to specify that. Maybe that one can be 5mm. So you make it a bit more butty. Now these two here are going to be collinear. So how do you do that? Is there a collinear? Constrain. Coincident? Is there a collinear constraint? FreeCAD. That's what I want to know. I find tangent to be the fastest way to do collinear. You just have to select two lines and hit the button. Tangency. Okay, that does make sense. Tangency makes sense. Oh, tangent or collinear. They actually renamed it. That's cool. Yeah, good. Now the depth of this, we're gonna want 3mm plus 0.4 for the 3D printer on each item, plus a bit of clearance. So we're going to go for the 0.6. We're going to go 3.6mm. And that should allow for those inaccuracies. All right, now we would like to be symmetric. Strain symmetric. Wrong selection. Select 2 points in a symmetry line. So 1, 2, symmetry. Boom. So now we can't move it anywhere but up and down, and we need to set some point there. So I'm going to get rid of this object just so I can see what I'm doing. We're going to select the origin point, which I can't select because I'm okay. I need to get rid of some other iPad. Bye-bye. Sorry, buddy. Get rid of the origin too. There we go. All right, now that there, we are going to have a distance of 6.7 millimeters. I just pulled that out of my butt. Maybe no, so I mean 6.6 because that's 0.6 is the clearance we gave it. Okay, that looks perfect. That looks good. Okay, now we want to extrude this thing. Add it. We don't call it extrude in FreeCAD. We call it don't be rude. Don't say extrude. Be a Chad. Say pad. I kind of want it the same length, so it is going to be 100. I'm going to go negative 100 though, because why does my one key all of a sudden not work? Why do none of my one keys work? What is this? What is this conspiracy I've got going on here? Okay, because we can't do that. We have to go reversed. Makes sense? Okay. That's good. So yeah, that's cool. That's a cool. Now we are going to build the post. So we can put a we'll get rid of the front clamp because we don't see that anymore. We are doing the back clamp and post. We've got this pad. I don't know why I've got a second pad here. I don't know what that's about, so I'm going to get rid of that. I think I clicked on the wrong thing. I think that's what happened. We'll select that, and we're going to add a primitive box. That is what I did. So add a primitive box. We're going to attach it to this face like that. Now, I wonder if there's a secondary reference that we can select. I've never really understood how the secondary references work. Inertial CS. Let's get rid of all this. Look, it doesn't matter. What I could do is just offset it. Now that doesn't make sense. Oh, reference 2. Okay. Wow. Wow. Reference 4. Why is it do? What is going on here? Crazy. Yay! No, I had my stuff arrive. Let's have a quick unboxing here. Really boring stuff, this. 960 ceramic capacitors. And the bigger one, which cost a little bit more, but it's worth having them. A massive kit of polyester capacitors. Gorgeous. Just beautiful. Wow. Slowly building up. These are quite small. That's okay. So these are picofarad ones. So these are like for radio. These are like for high frequency stuff. These are nanofarad, which is like, I don't know, they're for filtering. Well, electrolytic capacitors are good for filtering or power buffering, I guess. These are good for signal filtering and some, or like audio. So anyway, that's good. Tell you what, the shipping from AliExpress is getting really fast. It's a matter of days that came across from China. China. Right. Unboxing experience had. Got. So let's continue. So we got a reference of this face here, which is good. We now need a length. Oh my gosh, this is okay. Okay. I'm pretty sure. Now I need to try this. I'm pretty sure that in FreeCAD they did this thing, and I just want to give it a go before I actually continue any further. So in Fusion, what you could do, go like this, and you can create two closed loops, right? So now if we do that, we can like select this and we can go add wire is not closed. Maybe it's not that version. I think maybe it was in a, maybe it's in a like a beta build or wire is not closed. So if we just select a closed wire, like manually, and then we go pad, wire is not closed. There was an option of like allow multiple bodies or something. Ah, screw it. Not gonna mess around with that right now. Let's roll this back. Hide it away. Add that additive box. Attached to there. You know, I think I get this now. So if I wanted the box in the middle of it, I could go like this. I could go like this. Hold up. Can I just like get rid of all of that again? Okay, so reference 1 is that. Reference 2 is that. And that puts it kind of in the middle. And then reference 3 be this. Doesn't really work. It's like triangulating it. So it's not exactly what I want. So instead what I could do is actually use edges. Not only edges and wires. Interesting. What about not only vertices? Yeah, all right. Well, that's this. I don't get exactly how this works. The other thing I could do is create a screw it. I'm just gonna put it on the face of the object. That's good. Save faffing around. XY tangent to surface initial CS. I do need to learn this stuff. I need to spend some time on it. Now is not the time. I just want to build things. So if I select another reference though, if I select it under here, it's gonna totally screw it up. Okay. That's right. We'll figure it out. So width 12, 11.6. Length. What way is it considering length? That way. So I need to know the length of this line. Ugh. Length of that is 77. So we can go 77. 7 meters. And the height of that is going to be whatever that is, 5 plus 3.6, 8.6. Nope. Wait. 3. Width. But 8.6. And then we need to move it down. We need to okay. That's good. And then Z direction, X direction. So we're going to have 77 divided by 2, which is 38.5. I don't. If I put in 77 divided by 2, I think that. Oh no, it does replace it with 38. Okay. Right, so we've got this little tray thing going on. Now we're going to add another box in there. See, I feel like I'm building this from backwards. So I think what would be good is to have another reference plane. I think we need a datum plane there. Build one, and we'll select that, and we'll add a box, and that can sit on that datum plane. Yeah, that's much better, actually. Turn this origin off. It's good. And we're going to go back another 5 mil. I can't remember how thick we made the post. So maybe if I go 7, and that's 10 in total. So the width only needs to be... Datum plane 3 flip sides, maybe? Is that right? Okay, now what do we say we made the post? It was 80 mil. 80 mil. So we want that clearance on either side of like 0.5 millimeter plus 0.2. The 0.5 millimeter either side is 1 millimeter plus the 0.2 3D printer clearance per side is another 0.4. So 1.4, so it's going to be 81.4 millimeters wide. That is so wrong. No, it's not actually. I think we've just made I think we've made the post, the holder thing too wide. So datum plane, we can... Yeah, I think I need to reimagine that a little bit. I don't really want to make this any wider. It's only 77 though. It's not very wide at all, is it? I probably actually could. I probably could go out to 100. It might be the best way. So here we've got 77. 77 to 100 is 23. An extra 23. So if we go to 7894, that's going to be 100 wide in total. Sometimes the constraints aren't that smart. We'll get rid of that. Drag that there. And pop the constraint back on there, and we're good to go again. Tidy these up a little. Tidy these up so we can actually read them. Go. We'll close that off there. That looks a little better. It's still freaking huge though. Like, it's not exactly what I wanted. So we need to fix this up now. $77. We said it was now going to be 100, yeah? 100 in total. And so with this, we can go minus 50. And then with this box here, which we now have there, we've got a width of 81.4 in total. So I need to move it forward. So attachment offset, that's going to be, is it X? So this is going to be 100 minus 81.4 divided by 2. So that's 100 wide minus the length of the thing itself. Gives us the free space, which is that space plus that space, and then dividing it by 2 puts it to... Okay. Stand by. What did I put? Oh, that's not a good. It's kind of annoying that it's like kind of upside down. X, Y. So we could do it around y-axis 180 degrees, right? And that way, if I adjust the height, I mean, the width. What? Oh, it's because all the axes are screwed up. 0. Z. No, 0. 180. I don't know. I don't know anymore. Maybe it's actually the datum that's in the wrong here. What if I go flip sides on that? Then we go box. Yeah, that's totally screwed it up. Or has it? Yeah, no. God, it's real consistent on... I mean, this is why sometimes doing a datum plane not on a face, like building stuff on faces just seems really dodgy in FreeCAD sometimes. So we've got this ZX plane. I reckon might be all right. Object ZX. And that way, okay, we'll turn the origin back on. So we'll go to the ZX plane. Error. Attached to a non-geo feature. I'm pretty sure that I've attached an origin, a datum plane to... Yeah, okay, I just clicked on the wrong thing. Let's have a look at that there. Let's have a look at that there. And we are going to move this datum plane. Why it keeps bleeping at me like that? We are going to move this to... Maybe we're not going to do anything. The Z is depth. So we're going to go back this far, which I can't remember how far that was. I think it was 100. Yeah, that's good actually, because I do want it growing out of there. So that's okay. That's fine. We'll use that. Now we'll go into the box here. And I think we'll just reset it to 0, 0, 0 for now. And we'll start it growing. Yeah, that's better. Okay, that's what I want. Jeepers creepers, that took ages. All right, so we want it started down the bottom here. So we want to move in Y direction down to the bottom. 11 minus 11.6. Okay. And then we want to go in this direction. Whatever the heck I said before, which was, it was like 100 minus 81.6 divided by 2. I can't remember. No, it definitely wasn't. So it's positioning. Really means I've done something wrong. If 81.4. Okay. So right. So let's try this again. Negative 100 minus 81.4 divided by 2. That doesn't sound right at all. Actually, I think this just needs to be 81.4 divided by 2. Because we're not going from here this time, we're going from the middle. And now edit the box again. We are going to add some height to this thing. Oh, this is where I don't know how much height to add. I think I made the other one 100 high. So if I make this one 100 high for now as well. Always weak later on. That looks ridiculously huge. That's what she... Front clamp. Add sketch. 2 dimensions. 50 and 50. Nope. Not 50 and 50. 50 minus 3. 47 and 47, but I don't think that gives us any clearance on the sides. So we need to add, we'll do the 0.5 mil plus 0.2 each side. So 0.7 mil each side. We'll do the old 0.6. 0.6 is a good number. So we'll go 46.4. And that gives us a little bit of leeway there. 3D printing errors and for clearance, normal tolerance. Okay, so that's coming together. So now the glass frame and mount is the other question that we have. And this here was 80 millimeters. And I've made that 81.4. In other words, not wide enough at all. What was I thinking with that? 81.4. How did I come up with that number? .4. I don't know. Let's mess around with this again. 81.4. So we need 80. We need 80 plus 3 plus 3, which is 86. Now add the tolerance each side. And we're using that magic 0.6 number. So so we got 86 plus 1.2, which is 87.2. And now we need to recenter it again. $87.2. I'm going to use a calculator for this because I can't be bothered working this out again. So we had 81. We got 87.2 minus 81.4 is 5.8. So we're going to go 40.7 plus 5.8 is 46.5. Negative 46.5. Wow, that's so wrong. Cool. I have a feeling that all I need to do is 40.7 plus half of that, which is 2.9. 40.7 plus 2.9 is 43.6. Don't ask me why. I don't even. All right. We're getting somewhere. We're doing something. Now we need to cut out of the back of this the slot for the screen holder. So we're going to do a subtractive box, which is going to be attached to this. And the height, we're just going to make it the entire height of the thing. We are going to move it in the Y direction down. Well, we might do a little bit of an overlap here. We'll allow it to overlap. So we'll just cheat a little bit. That's okay sometimes. Width, yeah, so we'll just make it a little bit bigger. Width, no, height is going to be... So that's going to be that 3 mil. I can't remember how thick the glass mount thing, how thick is that? I think that's 5 mil, right? Needs to be quite strong. Yeah, 5 mil. We want 5 plus clearance. So that's going to be, we're going to give ourselves 0.5 mil mechanical clearance plus 0.2 tolerance for the print. Our magic 0.6, and I think we'll go. We'll be fine. So we'll turn that off. Box number 11 there. We're going to go length, height. What did we say? 5.6. So this isn't quite right, what I had planned here. Because how thick do I want that? Like, I want that like 3 mil. So we really want to go back 3 mil plus our clearance, which is 3.6. And then we want this thing as wide as the post plus the clearance each side. So we want that to be, that's the 81.2, right? 81.2. So then 81.2 divided by 2 is we are going to want this. So negative 81.2 divided by 2 millimeters. Sounds good to me. Looks good to me. I mean, this would be reasonably strong, and I'm probably exaggerating in my mind how heavy the glass thing's going to be, because in some ways, yeah, I don't know. Maybe I'm worrying a bit too much about that. Like ideally, and this is where I fall over a little bit in some of this 3D design stuff, is like, say if I wanted to adjust the height of this, I should only have to adjust one property, you know? I should be able to say this post here is this tool, and it should adjust and everything else should work. But I don't think that is how I've set this up. I have been, not rushing, but like I definitely haven't been thinking about it as I probably should. In terms of being kind to myself, the design. All right. So look, let's leave that there for now. And I think I'm going to go into assembly. We've got, yeah. I'm going to view this at the front on here, and we'll go in here and adjust this. Eyeball it for now. Okay, cool. Now with this one, we're also going to create an assembly file. Whoops. Wait. What did I just do? Go in here, create assembly. Go in here. Now this assembly is going to have all of the stuff. So add parts. And we're going to add front clamp, back. Missing that happening. Range. Dude. No. Right, so we're in the assembly workbench. We want to insert components. For some reason, I'm missing... Maybe I gotta save first. No? I'm so confused. Is it because they're invisible? It disappears. What? I don't get that. Works fine in here. Does it have to be outside of... Really strange. It's almost like the assemblies actually shouldn't live there. Maybe I should be putting them outside the root project. Okay, so we're going to call this tablet mount post. So this is going to, yeah, right. Okay, so now we can add the stuff in. We're going to add that in. You always want to ground the first inserted part automatically. You need at least one grounded part in your assembly. But I think the post is going to be That's going to be the grounded. That's going to be the grounded part. We'll get rid of all this. This is getting confused. Oh. Get rid of. I can see an origin somewhere. I don't know where this comes. Here is it. So backclamp and post. Is there a way we can edit the placement? Just zero it off. 0, 0, 0. And there must be a thing where you can go ground base feature. We're in the assembly. Right, so here we go. Toggle grounded. That's cool. Alrighty. Now, can you make an assembly of assemblies? The other thing I wanted. We got this glass frame thing. So, really, like, what I want is another assembly. Oops. Go out of here. I just want an assembly in the current document or in the current active assembly. Limit of 1 root assembly per file. Create a fixture. Now I just want to create another assembly in the document. Is that possible? Is that a thing I can do? I can't say I fully understand this workload. So we'll call this one the root assembly. Okay, so then maybe that was the problem I was having before with the thing. I was trying to, yeah, I don't know. Part of it. All right, tablet, post, and mount. We are going to now look at this. We're going to wrangle that around 45 degrees. Pop that. Yeah. Walk it forwards a little bit. Oh wow, that's completely ran the wrong way. What have I done? Lol. Okay. See, that's way too high. That is so high. That is crazy. That is not right at all. That is okay. It's good to see it together like this because, man, gives you a real idea of what you've done wrong. So let's go back into this. Turn that off for now. We're going to go back into tablet holder. Glass post. This is way too high. So it only needs to be like enough to stop it tilting forward and back. So what I could do actually is move it down, but then the printing it is going to be quite difficult. So I think maybe I just trust in the integrity of the plastic, and I think we just need to make this a lot shorter. And hey, first prototype, it might break, but see what happens. So what have we done there? That's the base, which okay, and the box is the back wall, and then we created that datum plane, then we got this box here. So this is the box that we just need to reduce the size of, I think. So we've got this width of 100. I think I'm going to bring that all the way back down to like 20. Because the thing is the glass is even 20. I'm going to go 20. And we can enable that again, and that still works. Okay, so now if we have a look at the assembly, yeah, that's much better. And it's going to be pretty rare that you're going to have to bring the glass up that high. And that's a very large tablet. So I think that's a large tablet you got going on there. Glass and frames. So we are going to transform that. Going to bring it down. So what I would love is a way to adjust the origin on this. So my up and down on this object is actually in line with that. I mean, I guess that's the point of joints. Why we create joints between these. A linear. So maybe that's what I should do. Maybe that is what I. And a joint. Joints within the assembly. Right, so in this assembly is the root assembly. Okay. A joint object. Back clamp and post. That. But can they not be from separate assemblies? You'd think they would be able to be, right? Slider. That's what I want. A slider joint. Create a joint between. So I don't know how to select. I've got this origin showing up to. No, it's not an origin. It is a datum plane. Okay, so tasks, slider, we're going to create glass holder mount, back clamp and post. So I think I think I need to actually create the joint in this assembly here. But it's not letting me. Do I need to save first? recompute. F5. This is so frustrating. Why can't I click on any of this stuff? What? Oh, it's because I'm still in the task. That's why. That gets me quite a lot, that does. So I wonder then if I select the object. So if I go back, clamp and post, and the glass holder mount. No. The learning curve here, this one. I don't know what I'm doing. So, I mean, this one makes sense, all right? So what I can do is double click on this one, and then I can choose these two objects here, and I can create a slider joint, right? Go okay. So we've got these joints here. We've got this. Yeah. This on the wrong axis. So the slider rotation 90 degrees. Nope. Reverse the direction of the joint. How do you do this? Is it offsets? We've got to adjust these joint connectors. Toggle freeze. Placement. That's probably what it is. I'm not super sure. I can tell it's like wrong just by it's only moves to want to move along the Z axis. So there must be like a create a ball joint. There must be like something where we can create like an origin for the movement for the joint strain. We could change the axis, right? So we could go y-axis 1, z-axis 0. And then like recompute it. No? Ah, this is a new one on me. What's going on here? Detach. offset. So maybe it's not the offset, maybe it's the placement that I need to play around with here. Placement. No. No. Why do you want to go up and down, not freaking that way? Okay, I need to learn. This is the thing that needs to happen. I need to learn. Going wrong there. That's what I want to happen. Stop there, move to there. Stop there, move to there. Stop there. This joint is round the wrong way. Click on the joint. And we go. So maybe this axis doesn't actually do anything, you know? Got this placement. Should be like 90 degrees. No. 90 degrees around the z-axis. So what does that do? Like if I put in 90 degrees, nothing. It just resets it back to where it was. Now if I go back to what the offset used to be, is there a way to reset? Placement 2. I don't know. I'm going to get rid of these. We're going to roll back. Roll back. Revert. Okay. Well, it's good to save at regular intervals as well. All right, what's the time? 5:30. About food soon. I haven't recorded anything. I haven't done my... So we can transform... Can't. This is nuts. Oh, so what I need a grounded assembly to make joint. Gotcha. You gotcha. So we have a grounded assembly in the assembly. Something needs to be grounded in there. So this glass and frame, now we can make a joint between these two. We can make a slider joint. Now that is, see, yeah. I mean, kind of, but not really. Okay. So this might actually help because I'm able to see what's going on better here. So let us have a look at the slider joint, and what we can do is go joint connector 1 versus joint connector 2. I'm not sure which is which. So what we can do is have a look at this placement here. Play around with some angles. Pretty sure that angle doesn't do anything. We've got axis. Tends to not do anything either. So what about changing the position? Like if I just go like 20 mil, it resets it to 0 every time. Is that because joint connector 1 is on the locked one? So I can't adjust that obviously, but joint connector 2 maybe this. So let's see where it actually. Hey, there we go. Right, okay. This is now making sense. So it's like it's always on the z-axis. So we've got this joint connector. So I want to see it, but now it's disappeared. Okay. There's a bit of faffing around with this. Yeah, so that's around the z-axis. Oh, so we can just... Okay, so I want... the offset to be around the... Now we're actually doing stuff. Now things are actually happening. Okay. See, that's good. And now we go angle. Yeah, 45 degrees. Okay. I mean, see, that kind of works. I'm not 100% the issue. I'm not 100% sure of how, but now I need to move this across here into the center. So, now is that going to be, see, now the placement has changed, which is interesting. Are these two things like intrinsically joined? Are they just the same? I don't know, but anyway, we want to go along the x axis by like whatever that is, 229 divided by 2. Now we're talking. Now we're cooking. Now we want to adjust the Y position. Now that is interesting. See, it's quite fascinating that the placement changes. So maybe this, yeah, this joint connector 1 we could put back here. But it didn't seem to let us adjust anything to do with that. Oh, maybe we can. Yeah, it's just good. Yeah, whatever. Let's go like 80. Let's go like 100. Let's go like 106, 110, 109. Totally guessing. 108.6. Okay. Beautiful. Looks about right. Oh, yeah. Do I have no clearance there? I do. I've got a little bit. Doesn't look right. Yes, because I've got more clearance on that side than that. Look at that. Oh, that's right, because I hand positioned some of that stuff, didn't I? That'll be partly why. Cool. Oh, this is backwards as well. Oh, God. Okay. 180. Lovely. This is not the best way to do it. I've completely lost track. In case you can't tell. I wish there was a way to just like adjust it one by one without it resetting to this craziness. In fact, it's tell you what it is. It'll be joint connected 2. It'll be the offset of that is in place. I need further down. So we need it by like. I mean, since it's 45 degrees, it's easy to do. So I should just be able to go like 20 and 20. Or in this case, like -20 and -20. So that all did it. Oh, okay, maybe 20 and 20. But I want it here. That works. That doth work. So I feel like I want the top of that. So we're going to lift the Z up to the top of that, which is hard to do because 2, 3. We'll go to 8. Why can't I do that? Doesn't let me sometimes. That's strange. Sometimes it lets me do things and sometimes it doesn't. Don't know what the rules are about that. Yeah, weird. But what if I go offset? 8? Yeah, that does work. Placement versus offset. I need to read up on this. At the moment, it's all a bit of a dark art and a bit of guessing. So position here, Z, we are going to go back to like, I mean, what happens if we go like -3? again. That looks about right. So if I go negative, no, it doesn't. It's not enough. 5. About 8. That works. Works well. Cool. Yeah. All right. So now we can put some constraints on this thing. We can go distance max is going to be whatever that is. Well, which I guess is going to be about 90. This prevents placement too from recomputing. Enable custom positioning of. Right, okay. So this is the attachment offset. This is the local coordinate system within reference. Oh. Okay. First reference. Only used by the gear joint. The distance of the joint. Okay, so these actually do nothing. I thought there was a maximum and a minimum. There is. Min length 0, max length like 90. Like that. Except we want max length of about 85 instead. No. Max about 82 instead. That. Okay, and what about just 80? Let's just go for 80. Boom. Cool, cool. It's good. Now, save. And let's have a look at this slider one, see if this works. So we need to go in here. We've got a grounded part. Turn off the joints for now. We don't need to see them. We've got this grounded joint here, what is the grounded joint? This is the object to ground glass. Oh, glass and frame. Okay, that's not what I'll be looking at right now. We'll turn that off. I need to be in the tablet mount and post, and we have got this grounded joint, which is the back clamp and post. Good. Then we are going to add a joint between these two things here. Slider joint. And we'll go, okay, we'll come back and do the minimums afterwards now. So this is all backwards. So we need to turn on the slider joint. We need to go joint connector 1, which I believe is actually not quite in the right place. I want to bring that down that surface. Just above that surface, we want to give that clearance 0.6 mil. So we'll go position Z, change that. 0. Actually, that's perfect where it is. No, so that one is fine. This offset 2 that we need to change. And the axis, I believe, that we want is Y. Z is 0. And maybe X. Still don't 100% get this, but we'll get there. We will get there. Which is just an easy way to select this joint and just go attach here, like the attachment properties of other objects and stuff. Okay, slider. So we've got axis Y, angle. Yeah. The local coordinate system. So that is what we need to change, is the local coordinate system. So I'm going to put this back to how it was. It's going to go like this. And then we are going to change this like -90. This is where detach comes in, I think, because by detaching it's unlinking offset and the placement, whereas the offset would move the placement, but now I can change the placement separately. I think I was working on the wrong one. It seems to be moving that. So we got like 90 degrees there. That's better. It does seem to like move along the Z axis. I know there's got to be some documentation about that where I can double check that and make sure it's correct. So at the moment, I mean, this looks pretty good. I wouldn't want it to go much further than that. There's about 10 mil roughly there. And I want it to go all the way back into here. So we are going to set maximums. It's so annoying. Okay, so I need to keep detach set to true to stop these things from kind of syncing, I guess. 9 position, no, rotation, axis, 90 degrees. A grounded object moved. 173 times. Now hold up though. That's grounded in the... Is it complaining that this is grounded? So like the grounded joint here is the whole assembly though. Oh, so I suppose it does move, actually. Object to ground. So I guess what we actually want to ground here is the back clamp and post. Because that ain't going to move, right? And so then these grounded joints, I actually probably don't need that. Maybe I don't need that either. That's definitely not doing what I want it to do. Tablet mount and post. Oh. Yeah, I don't want to see the part. Okay, so I do want that grounded. I don't want that to move. The problem is the grounded joint was referring to the whole assembly. So as the assembly changes its dimensions and shape, it's like the grounded thing's moving. So we needed a part that's going to stay still. So this, in relation to the rest of the assembly, it is. So we're going to go in the tablet mount and post, we're going to create a grounded joint out of that. The slider can have a min length of that and a max length of like what, 60? Oh no. Okay. Well, this is a pain in the butt. So the placement, we want the z-axis facing down this thing. Unnamed joint 001 is unconnected to a grounded part, so it's ignored. Oh, does that need to come first? It does. All right, so maybe we delete that. Now I don't know what this is about. We go front clamp. We need to turn this thing around, roughly position it where it should be. That'll do. That'll do like that. Okay, and then what we can do here is now we can create this joint. So apply to joint. And we know that this doesn't work. It just makes it, oh, okay, that didn't fall. Slider will go, okay, now that just makes it go up and down. So now let's see if we can get this sorted nice and quickly. So joint connector 1. This is annoying because I wish it highlighted the joint connector that you're working on. It's hard to know which one you're actually clicking on. Yeah. I mean, so I guess, I don't know. Placement, right? So the local coordinate system within reference 1's object. Reference 1. Okay, so we need to figure out what reference 1 is, which is, you can actually see that. Reference 1 is assembly 2. Front clamp. So this is joint 1. Okay, fine. So what we want to do here is detach of the first connector of the joint. The attachment offset of the first connector of the joint. Now why? Now because what that's going to do is it's going to rotate the whole object because it's linked to placement. So we need to detach these two. We need to work on placement. We need to place the joint axis first. So we're going to go 1, 0, 90 degrees. We're going to change the position of it. We're going to pull the Z back. Is this like in the what space is, okay, so this is in the global axis space. So we're going to pull it back Y, reset Y, I guess, by like however many mil that is. 12. All right, and then be nice to be able to flip that axis around. So that axis is X, so we could probably go -1, and we have it around that way. So after we've done that, does that mean the joint actually works properly? It does. Yeah, that's pretty cool. Okay, I like that. I don't know what this is on about. Unnamed joint 001. Rounded joint 003. Back clamp and post. Yeah, I mean, okay, we did that. So this joint here, we're going to have to change. Minimum length is going to be like -15. Max length is going to be like -80. What? Why does it do that? Oh, this is totally screwed up. I just said adjust the minimum maximum length. I didn't say do anything else. We're learning quirks of software is kind of fun. Well, fun. Lol. Sync sub-objects. As is disconnected. So we've gone x-axis and we've gone 90 degrees. Now the question is, why have we done that? Sense. Oh, this is so broken. I think I'm gonna have to start again. I think I'm gonna have to delete all of that. I don't know. I think I'm gonna have to reposition this. We're gonna save, right? So we're gonna recompute everything and we're gonna save. Now, we want to join this back clamp and post to front clamp. So what we need to do first is ground this object. And then we want to link these two together. One, that's two. Maybe these need to be switched around the other way. Because we built that off that. So it shouldn't really matter. So we should go back clamp and post, then front clamp, and we'll create a slider link. Yes. Show advanced offsets. Okay, so these are like transformation matrices or something. So we can go offset 1, offset 2. Ah. Yeah. Euler angles. I don't know how to use those. So we're going to go apply incremental changes. We are going to go X. No, we're not. Oh, this is annoying. Okay, reset. Reset. Wind it back. XYZ. X. Z. Angle. Okay. Shift click for opposite direction. Reset. Center. Use center of mass. I don't know what is going on here, but it's not what I'm trying to do. It's not helping me at all. Apply axial. That actually axial. Translation. Right. Okay, okay. No, I'm getting all right. I think this is starting to ring a bell with something like we want to go negative 1.5 here. Now we want the thing rotated around the x-axis. 90 degrees. Yeah. Okay, this doesn't look great, but I think I'm actually on the right track. I don't know why it's still saying it's unconnected. Really annoying. Curious, right? Okay, let's just apply this and see what the heck happens here. Okay, all right. So Z is sliding along the Z axis. Okay, so that's cool. That kind of aligns those two. So now we need to adjust the advanced offset of this one. So we need to basically go around the X axis again. Make that 0, and we'll go like 90 degrees, but negative 90. Negative. Yeah. Cool. Go apply. Go okay. So that, okay. Okay. It's starting to become clear to me. Very slowly. But it is. Now, the translation here, we got Y. Z is... I wish I could like... Maybe I can. Okay, so now this is kind of making a little bit more sense to me now. So if I can go in here and joint 1, I can now actually adjust the placement. So you've got to go in order. So you've got to go joint 1 first. You've got to define like the Z axis of joint 1 first, and then you've got to match it up to all the ones afterwards. So this one, if we go like negative 1.6, maybe it's offset I need to adjust. Yeah. If. That's good. That's good. Okay, we'll save that. And then we'll do the joint connector 2. And in this case, we can change the offset a little bit along the Y axis. We can maybe decrease that a bit. Like that. I don't know what this is talking about. So that's a little bit annoying. And then this slides like that. So now we should be able to, without screwing everything up, we should be able to define a length min, which is 0. Activated joint. Is there a way, is there the toggle switch, enable length? There we go. Okay, so length max is going to be maybe, this is the maximum limit along the Z axis, so negative 80. Yeah, yep. So we'll go a little bit more, 90. Oh, perfect. Perfect. Oh, I don't know what's going on here. clicking on a bunch of random stuff, but that's okay. That probably can't go that far. So this is the issue here, is how much space do I have between these two? Now, I did design this around the iPad, and it's only just big enough for an iPad. So that's probably, honestly, this is where the compromises are going to come, because allowing for a minimum size as well for a phone. But I mean, a phone can just rest on this. It doesn't need to be clamped as much. Or perhaps we could build a smaller clamp. Oh, that seems a bit easy. Do that. I don't know. I just don't know. I did have an idea. I mean, that's the thing, right? It's this doesn't need to be that long. That can be shorter. This can be longer. The base can be longer. And that allows this thing to slide. I just realized I've got no lighting. Just suddenly got very dark. Quite funny. Alright, and W LED is not helping all being on maximum brightness right now. This is why I need an audience. Why I need people here to tell me what's going wrong. I can't look after myself. Okay, this is 6:15. I gotta go. I gotta sort out dinner. Alright.